Hi, this is Unit 5, Part 1, and we are doing solving systems by graphing. This is kind of an Algebra 1 review, so we're going to do it kind of quick. And our objectives is to solve systems of linear equations by graphing and use graphing to identify systems with no solution or infinitely many solutions. And we'll do one of each of these types here and a couple that are just regular graphing. And when you solve a system with graphing two equations, you graph both equations in the coordinate plane, and then you find the coordinates where they cross, and those coordinates are the solution to the system. And that's basically all you're doing. You're graphing two lines, finding out where they cross. So let's look at the first problem, example 1. We're going to graph these two equations, 2x plus 3y equals 6 and 2x plus y equals negative 2. I'm also going to show you in class how to use a graphing calculator. I know you've done this regular graphing in Algebra 1, and so we're going to use a calculator, graphing calculator to use these, and it'll make things real quick. But for now, since we don't have the graphing calculators, I'm going to show you the old-fashioned way. And the easiest way to graph lines is to put it in what's called slope-intercept form. Slope-intercept. And the intercept is the y-intercept. And the slope-intercept form is y equals mx plus b. You probably remember that from Algebra 1. I don't want an equal sign there. I'll put... Okay, slope-intercept form. And then again, the intercept is y-intercept. B is the y-intercept. So I'll call it y-int for intercept, short for intercept. M is the slope. So if we take 2x plus 3y equals 6, and we solve for y and put it in slope-intercept form, we subtract 2x. And you can't really subtract 2x from 6, but we want the 2x in front because it goes mx plus b, and the 6 is the b part. So we want negative 2x plus 6, because 6 is positive, and that equals 3y. And if we divide by 3, but we got to divide each number over here by 3. Y equals negative 2x, or negative 2/3 x, sorry, plus 2. Now the plus 2 means that's the y-intercept. So this thing is going to cross the y-axis at plus 2. And the negative 2/3 is the slope. But remember, slope is rise over run. So how high you go up over how far left or right you go. That's what run means. And the run gets the negative. So basically, instead of thinking of the negative up here with the 2, we could think of the negative up down at the bottom with the 3. And negative means run left. If it's a positive on the bottom for the run, if it's a positive fraction or a positive whole number, you would run to the right. And so we're going to run 2 up and 3 to the left from the point that we just graphed from the y-intercept, which would be 0, 2, would be where we cross the y-axis is at 2. So we go 2 up and 3 to the right from there. 1, 2, 1, 2, 3. We get another point right there. And if we do it again, we'd go up 2 and 1, 2, 3. We could keep going up 2 and over 3 to the left and keep making points. And if we go the other way, we would go right 2 and down 3. No, I take that back. Down 2 and right 3. Went backwards. Just reverse everything. Down 2, right 3. Down 2, right 3. Down 2, right 3. Okay, so we got all our points there. And I'll try and draw a nice pretty line. I can't really do it with this iPad. But you can see the points, and that's the main thing, because we're going to find out that one of these points is going to cross our other graph, which is 2x plus y equals -2. If I solve for y, I'm going to subtract 2x. But again, I can't really subtract from -2. I'm going to put the 2x in front of the -2, so I'll be minus 2x minus 2, because that's a -2. And my y-intercept is -2, so I know this graph is going to cross the y-axis down 2. And my slope is going to be -2, which is really 2 over 1. -2 over 1. And again, the negative goes on the 1, so it's going to run to the left. It's going to go up 2 and 1 to the left from the y-intercept that we plotted. So we're from the -2 on the y, we're going to go up 2 and 1 to the left, and then up 2 and 1 to the left, and then up 2 and 1 to the left, and there's where we cross. I don't really need to plot any more points. I can draw the line in, but that point right there is where we cross, and that's the answer to the system. It would be, the point would be -1, 2, -3, and up 1, 2, 3, 4, -3, 4. So the answer is -3, 4. Okay, pause here, try your checkpoint, and I'll give you the answer when you come back. All right, the answer to checkpoint 1, you should have gotten 1, 2 as your answer, and you can do the graphs and stuff. Let's look at what happens with the different type of answers that we can get. So you have 3 different types of answers you can get with systems, and you get exactly one ordered pair solution. That's what we just did. If we get one point where they cross, that's exactly one ordered pair. You can get no solution, and that happens when you have 2 parallel lines, like in this picture right here, 2 parallel lines. They're never going to cross, so we can't have a solution, so that's no solution. And you can get infinitely many solutions, which means the 2 lines are identical, and that's why they drew a big dark line on this. It means the 2 lines are the same exact line. They touch in infinite spots, so it's called infinitely many solutions. So let's look at a couple of those, one of each. We already did the one solution in example 1. Let's look at example 2. We're going to graph. And we are already in slope-intercept form. And so 3, we don't really have to do anything to these equations. 3 is the y-intercept for this first one. So we're up 3. And the slope is 2. But again, remember that's 2 over 1, and that's my rise over my run. And from my y-intercept, I'm going to go up 2 and right 1 this time. Up 2, right 1. Up 2, right 1. Up 2, right 1. And then if I was going the other way, it would be left 1, down 2. Okay, you could keep making points, but draw your line in at this point. All right, so my y-intercept on this one is -2. So we're going to be down 2. And my slope, again, is 2, which would be 2 over 1. But you see the slopes are identical. And if the slopes are identical, that's going to mean you're going to have parallel lines. And so if I took from here and I went up 2 over 1 again, and I go up 2 over 1, and I could keep going, but you're going to see a line that goes like this. You can see they're parallel. And if they're parallel, you get no solution. Let's look at example 3. They're not in slope-intercept form. So let's look what happens when we do put them in slope-intercept form. On this one here, we're going to subtract the 2x, and I'm going to write it up here, on each side. And what I would get is y equals negative 2x plus 3, because the 3 is positive. And if I subtract the 2x and I want it in front, it's a negative 2x. And this one here, if I want to solve for y, so get it in slope-intercept form, I subtract 4x this time. And what I get is 2y equals negative 4x plus 6. And then I got to get the y by itself, so I divide by 2, but I divide each number by 2. And when I do that, I get y equals negative 2x plus 3. And you can see that when you do that and you solve and put it in slope-intercept form, you get the same equation. They're both y equals negative 2x plus 3. So I can graph that equation. It's up 3. The slope is negative 2, so that would be negative, or 2 over negative 1. So I would be up 2, left 1, and keep going up 2, left 1, or I could go down 2, right 1. Either way, you get the same line. And if it's the same line, you get infinitely, I spelled that wrong. Let's see. Try that again. There we go. Infinitely many solutions. Okay? So those are our 3 options. You get the same line, you get infinitely many solutions, you get parallel lines, you get no solution, or if they cross, you do get a point, 1 point for your solution. That's all for Unit 5, Part 1. I will give you your assignment in class.